Mr. Caldwell?
Hello, Codette. You're early. How can I help you?
Sorry to bother you before class, but I have a math question. I was trying to solve some extra problems about quadratic equations on my own, and one of them asked about something called the discriminant. I don't think we covered that in class. Can you tell me what the discriminant is?
Absolutely. And I'm impressed that you're doing work outside of class. The discriminant is just a word for something we have talked about. Look at these three parabolas. These are the graphs of y equals x squared minus 1, then y equals x squared, and y equals x squared plus 1. Basically the same parabola, just shifted up and down, right?
Right.
In class, we've talked about how that one little difference, adding or subtracting 1 at the end, moves the parabola up or down by 1 unit, which makes a big difference in how many x-intercepts we have, right?
Right. The first parabola crosses the x-axis twice, so it has 2 x-intercepts. The middle parabola turns around right on the x-axis, so it has just 1 x-intercept. And the last parabola never even reaches the x-axis, so it has no x-intercepts.
Exactly. These three examples show us what all parabolas are like. A parabola can either touch the x-axis 2 times, 1 time, or 0 times. That's it. And the discriminant is a tool that gives us that information. The discriminant doesn't tell us where the x-intercepts are, but it tells us how many x-intercepts a quadratic equation has, either 2, or 1, or 0.
You make it sound kind of simple, Mr. C, but in the problem I was doing it looked complicated. There was no graph. It just talked about the equation, not a parabola.
I know what you mean, Codette, but now that we understand what the discriminant is, we're going to be able to figure out that kind of problem. When we look at these graphs, it's very easy to count how many x-intercepts we have. But imagine if we didn't have the graphs. Imagine if all we had were the equations. Suddenly, it's much harder, right? How can we possibly look at a quadratic equation by itself with no graph and figure out how many x-intercepts it's going to have? How could we possibly tell, just by looking at these three equations, that the first one has 2 x-intercepts, the middle one has 1 x-intercept, and the last one has 0 x-intercepts?
Ooh, I think I know. We learned this in class. The x-intercepts are the points on a graph where the y-coordinate is 0. And we can figure out those 0 points using the quadratic formula, or by factoring, or using any of those methods you taught us. Those are all ways of solving a quadratic equation for its zeros. That means all we have to do is solve our quadratic equation and count how many solutions we get. That would let us figure out how many x-intercepts we have, even when we don't have a graph.
Excellent, Codette. You're right. When we solve a quadratic equation, the answers we get are the x-intercepts. So we could just solve the equation and count our answers. But solving quadratics can be hard. The quadratic formula is not the easiest thing to use. So what if there were a faster way? That's what the discriminant does for us. It's a faster tool to find out how many x-intercepts we have. Here's how it works. Here's the quadratic formula. We learned how to use it in our last lesson. The quadratic formula lets us solve any quadratic equation just by plugging in its a, b, and c values, right? A is how many x squareds our equation has, b is how many plain old x's, and c is the regular old number at the end of our equation. But it's a pretty complicated formula. Luckily, the discriminant is just one part of this formula. The part right here under the radical, under the square root sign. The discriminant is b squared minus 4 times a times c, which is much easier to calculate than this whole formula.
You mean that little thing is somehow going to tell us how many x-intercepts the parabola has?
Believe it or not, yes. If we plug in a, b, and c, and we get a positive number as our discriminant, any positive number at all, then our quadratic equation will have 2 x-intercepts. If the discriminant is exactly 0, that tells us we're going to have just one x-intercept. And if the discriminant is a negative number, any negative number at all, then it's telling us that our quadratic equation has no x-intercepts. Its parabola just turns around and heads backward before it ever touches the x-axis.
I think I understand, but can we do an example?
Definitely. Let's find the discriminant of our three equations on the board. Our first equation is y equals x squared minus 1. The discriminant of any quadratic equation is b squared minus 4ac. So to calculate that, we need to know what our a, b, and c values are.
A is how many x squareds we have. In our equation, we have y equals x squared minus 1. So that's just one single x squared, which means A is 1. B is how many plain old x's we have, but we don't have any plain old x's in our equation, so B is 0. And C is the regular number at the end of our quadratic equation. That's minus 1, which means C is negative 1.
Good. Now our discriminant will always be b squared minus 4ac, so let's plug in those values for a, b, and c.
B squared means 0 squared, which is just 0. Minus 4 times a times c means minus 4 times 1 times negative 1, which is positive 4.
Good. So the discriminant of this quadratic equation is positive 4. And we said that when the discriminant is any positive number, that's telling us that we're going to have two x-intercepts. Let's confirm that by checking the graph of our parabola.
Yes, the parabola has an x-intercept at negative 1 and another x-intercept at positive 1. So it does have two x-intercepts.
The discriminant worked. It told us how many x-intercepts our equation had. It didn't tell us where they would be, but that's not what we use the discriminant for. We only use it for knowing how many x-intercepts, how many solutions we're going to have. Now let's try our middle equation, y equals x squared. What's the discriminant of this equation?
The discriminant is always b squared minus 4ac. So we start by figuring out the a, b, and c values for our equation. Y equals x squared. A is how many x squareds we have, which is just 1. B is how many plain old x's we have, which is none, 0. And C is the regular number at the end, but there's no number at the end here, so C is also 0. When we plug those values in to find our discriminant, we get 0 squared minus 4 times 1 times 0. That's 0 minus 0, which is just 0. So that's our discriminant, 0.
Excellent. That's right. And we said that when our discriminant is 0, that's telling us that our parabola will only have one x-intercept, one solution. Look at our graph. Is that true?
Yes, the parabola comes down and turns around right on the x-axis. So it only has one x-intercept.
Well done. Now let's try our last equation, y equals x squared plus 1. Tell me what its discriminant is.
The discriminant is always b squared minus 4ac. So we start by finding out a, b, and c. We only have one single x squared, so a is 1. We don't have any plain old x's, so b is 0. And the regular number at the end of our equation is plus 1. Which means positive 1, so that's C. So b squared minus 4ac means 0 squared minus 4 times 1 times 1. That simplifies to 0 minus 4, so our discriminant is negative 4.
That's right. And we said that when our discriminant is any negative number, that's telling us that our parabola will have 0 x-intercepts, none. In other words, its parabola will turn around and head backwards before it ever reaches the x-axis. So let's look at our graph. Is that true?
Yes, the parabola never touches the x-axis at all. That's pretty neat, Mr. Caldwell.
Now you know what the discriminant is. Just a quick way to figure out how many x-intercepts, how many solutions your quadratic equation has.
But, well...
Let me guess. Now you're wondering why it works.
Right. How can that one little part of the quadratic formula predict how many solutions we're going to have?
That's a great question. Look at our three discriminants again for our three quadratic equations. You calculated that our discriminants are 4, 0, and -4. Now look at our quadratic formula again. We said that the discriminant is just this part of the formula that's under the square root, under the radical. So think about what happens when we plug in 4 compared to when we plug in 0 compared to when we plug in -4 under the square root sign. Why did those three answers cause our whole quadratic formula to behave very differently each time?
Well, if we plug in 4, the square root of 4 is plus or minus 2.
Exactly. Think about that plus or minus sign in the quadratic formula right before the square root sign. It means that when we solve our square root, we're going to have to do two separate calculations with it. We're going to have to add the square root, which will give us one answer, but then we're also going to have to subtract the square root, which is going to give us a different answer. Since the formula is telling us that either of those answers will be correct, that means that we're going to end up with two right answers, two valid solutions. In other words, our parabola is going to have two x-intercepts. And that's what's going to happen anytime our discriminant is a positive number. No matter which positive number it is, the quadratic formula is going to have this plus or minus sign right before it. So we're going to end up with one solution where we add the square root and a different answer where we subtract the square root.
Oh, I see.
Now think about our middle equation, where the discriminant was not a positive number. It was 0. If we plug in 0 under the square root sign in our quadratic formula, what's the square root of 0?
It's just 0.
That's right. So in our quadratic formula, we still have our plus or minus sign, but now it's just plus or minus 0. Is that going to give us two separate solutions like we had before?
No, I get it now. Plus 0 and minus 0 give us the same answer. Anything plus 0 or anything minus 0 will just be the same number you started with. So that's why when our discriminant is 0, there's only one solution instead of two, because adding or subtracting 0 makes no difference.
Great job. Now here's the trickiest part. We've just figured out why a positive discriminant gives us two solutions and a discriminant of 0 gives us one solution. But why does a negative discriminant give us no solutions at all?
Ooh, I think I know. In the quadratic formula, the discriminant is the part under the square root sign, right? So if our discriminant is a negative number, like in our last equation where it's -4, then the quadratic formula wants us to calculate the square root of that negative number. But what's the square root of -4? Negative numbers don't have real square roots. Any number on the number line, when you square it, gives you a positive answer, or 0, never a negative. So anytime we have a discriminant that's a negative number, the quadratic formula will ask us to take the square root of that negative number, which has no real answer. That's why a quadratic equation with a negative discriminant has no solutions, no x-intercepts, right?
Codette, that's fantastic. You're right. So let's quickly review what we've learned. The discriminant is the part of the quadratic formula under the square root sign. It's b squared minus 4ac. It won't tell us what the solution to our quadratic equation is, but it will tell us how many solutions it has. To calculate the discriminant, first we figure out what our quadratic equations a, b, and c values are. Then we plug them in. If we get a positive answer, then a positive discriminant tells us that our quadratic equation has two solutions. In other words, its parabola has two x-intercepts. If the discriminant is 0, then our quadratic equation has only one solution. Its parabola has just one x-intercept. And if the discriminant is a negative number, then our quadratic equation has no real solutions. That means that its parabola never touches the x-axis. It just turns around and heads back before it ever reaches the x-axis. Does all of that make sense, Codette?
100%. Thanks, Mr. Caldwell.
Glad I could help. See you in class later today.